Let's start by reviewing the distributive property. So let's say we want to do 2 times 3 plus 4. Well, this means we have 2 of this quantity. So we have 2 3s and 2 4s. So if we want to evaluate this, what we can say is, well, this is equal to 2 times 3 plus 2 times 4. So you got to multiply 2 by each number inside here and add them. So what we did is we took this 2, brought it here, multiplied by 3, took that 2, brought it here, multiplied by 4. So we can do this with more complicated expressions. Let's say we want to multiply x plus 3 times x plus 5. Well, what we can do is this. We can say, all right, if a number is in parentheses, or if things are in parentheses, we consider them to be like one number. So this x plus 3 here, that's like our 2. So if I want to multiply x plus 3 times x plus 5, well, I got to take this whole quantity here, this x plus 3, I got to multiply it by x, and I got to multiply it by 5 and add. So I got to do x plus 3 times x plus x plus 3 times 5. And if I do that, I get x squared plus 3x plus 5x plus 15. So at the end, I'm left with x squared plus 8x plus 15. When I combine like terms, 3x plus 5x gives me 8x. All right, so let's say I have x plus 2 quantity squared. Well, that squared, the exponent denotes how many of these quantities are being multiplied together. So x plus 2 squared means I have x plus 2 times x plus 2. Okay, and we just learned how to expand this. So I have to do x plus 2 times x. And then I got to do plus 2 plus x plus 2 times 2. So I expand, and I get x squared plus 2x plus 2x plus 4. So I get x squared plus 4x plus 4. All right, now let's look at this next example. X minus 3 times x plus 3. So when I do this, well, again, same process. X minus 3 times x plus x minus 3 times 3. And now when I expand, I get x squared minus 3x plus 3x minus 9. And so I get, once I simplify here and say that negative 3x plus 3x is 0 x's, I can say that I get x squared minus 9. So something interesting happened. When we multiplied x minus 3 times x plus 3, we ended up with x squared minus 9. We didn't get a middle term in here. When we multiplied, say, x plus 3 times x plus 5, we ended up with x squared plus 8x plus 15. So the interesting thing is here is that our middle term disappeared. So this pattern will hold in general for any expression that looks like x minus a number times x plus a number. You will always get x squared minus that number squared. So you get this number, or this thing squared, so x squared, minus this number squared. So we get x squared minus 9. Okay, well, what if we want to go in reverse? Let's say we want to say, all right, well, I have y squared minus 36, and let's say I want to write it like something like this. Well, after the work we just did, what we can say is, all right, well, if I want to split it up like that, so I want to make it look like y plus or minus a number times y plus or minus a number, well, I should put minus 6 here and a plus 6 here. If I expand this, just like I expanded this guy up here, I would get y squared minus 36. Okay, so this is called factoring a difference of squares. So if you have something squared minus something else squared, if you want to split it up into two things in parentheses multiplied together, you got to take the square root of each thing. So square root of y squared is y, square root of 36 is 6. So let's look into this example. So here we have 16 times x to the fourth times y to the fourth minus 1. Well, if we want to factor this guy, we got to take the square root of this first term. Square root of 16 is 4. Square root of x to the fourth is x squared. Square root of y to the fourth is y squared. And then square root of 1 is 1. So I should do 4x squared y squared minus 1 times 4x squared y squared plus 1. But I'm not quite done yet. The reason is I can't factor this guy anymore. 4x squared plus y squared plus 1, that's about as good as it can get. But this guy, if you look, I have another difference of squares. So I can take the square root of 4x squared y squared and say that's 2xy. I can take the square root of 1 and say that's 1. So I can split up this first parenthesis here. I can split it up into 2xy minus 1 times 2xy plus 1. So I can keep factoring. And I can't forget about this guy that I had before. All I did was I replaced this first parentheses with these two guys. And this other guy is still along for the ride, so I have to include him. But now I'm done factoring. Okay, so let's look at another more complicated example. So in this situation, I have this clump of stuff here minus that clump of stuff there. And so the idea is I can factor this again as well, because I can take the square root of this guy and say, all right, well, the square root of 9 is 3. The square root of b plus 2 squared, well, that's b plus 2. Just like the square root of x squared was x and the square root of y squared was y, the square root of b plus 2 squared is b plus 2. And then I can take the square root of 4 is 2. The square root of b plus 1 squared is b plus 1. So I have 3 times b plus 2 minus 2 times b plus 1. And I should do 3 times b plus 2 and then plus 2 times b plus 1. So, all right, and I'm still not quite done now because this looks really messy. I have all these things in parentheses being multiplied together. It looks really ugly. So what I can do is I can keep going, and I can multiply out these things in parentheses here. So I can do 3 times b is 3b. 3 times 2 is 6. So I have 3b plus 6. And then negative 2 times b is negative 2b. Negative 2 times 1 is negative 2. And this next one, I can do 3 times b is 3b. And then 3 times 2 is 6. And then 2 times b is 2b. And then 2 times 1 is 2. And then I can add like terms in each of these quantities. So 3b minus 2b just gives me 1b, so I'll just write b. 6 minus 2 is 4. So in the first parentheses, I should just end up with b plus 4. Now in this second parentheses, I have 3b plus 2b. That gives me 5b. And 6 plus 2 gives me 8. So that's a very much nicer looking answer. Okay, now let's look at this guy. 2x cubed minus 8x. Now, this is really important. This is the first step in any factoring problem. It's called pulling out the greatest common factor. So I look at both of these things here, and I say, all right, this chunk of stuff, it has a 2 in it and an x in it. This chunk of stuff has a 2 in it and an x in it. So what I can do is I can pull out a 2x from each term. And I can say that this is x squared, and I can say that this is 4. So 2x times x squared gives me 2x cubed, and 2x times negative 4 gives me negative 8x. So these two quantities are equal.